Yeah, this is right. It's this, right? Because sigma 1, you just plug this in. You get this. I'm going to ignore the 1/4, right? Because it's just a constant. So let's look at that. That should be sigma 1 squared plus sigma 2 squared. You know what? I'm not going to do this. I'm going to do a completely different way. It's easier. Let's write the original formula. Let's expand it. So it's y1 squared plus y2 squared plus y3 squared, right? Minus 2y1, y2, no, sorry, plus 2y1, y3 plus 2y2, y3 minus 2y1 minus 2y2 minus 2y3 plus 1. Okay, this is just a straight expansion of the bit formula. I'm not doing plugging in just yet. I think this is easier. Okay, so remember this is bit representation. So y is either 0 or 1. And y squared is also 0 and 1, which means y squared equals y, okay, in bit formulation. So this is a good thing. Why? Because then I can get rid of this term. This is gone. I just don't have minus 2. This is gone. I don't have this minus 2. I don't have this minus 2. y3 squared is gone. Okay, so I end up with these cross terms and the linear terms. And now I'm going to plug in. Okay, so I'm going to plug in for the theta, sigma. Y1 is this, so I'm going to take this one term here. Okay, 2 and 2 cancels 1. So I'm going to have, okay, I'm going to write 1 more completely, and then I'm going to simplify from then on. Times 1/2 of sigma 2 plus 1, right? What is this? This is just 1/2, right? This term is going to be 1/2 of sigma 1, sigma 2 plus sigma 1 plus sigma 2 plus 1. That's what it is. I'm not going to use this. And this same thing applies to that, and then if I expand them all out, and it would be 1/2 of a whole bunch of things, right? There will be sigma 1, sigma 2, a sigma 2, sigma 3, and a sigma 1, sigma 2. These are all the cross terms, right? And what else? I will have 1 sigma 1, 1 sigma 2 from the first term, a sigma 1 and a sigma 3 from the second term, so I will have 2 of these. So I will have 2 sigma 1s, 2 sigma 2s, and 2 sigma 3s. Finally, I have to add 3, right? The 1 will appear 3 times, plus 3. So this whole thing is inside the 1/2. Now what we did is to take care of these. And then we need to look at those 3 terms. Okay, so what is y1? y1 is just 1/2 of that, right? So minus 1/2 of these y1 plus y2 plus y3. What do I have? I would just have sigma 1 plus sigma 2 plus sigma 3 and a big 3 to it, because everyone has a plus 1 to that. That's this second portion. And finally, add a 1. Okay, so this is, now I'm translating to spins. And I can just collect terms. This will in the end be 1/2 of the cross terms Okay. Cross terms. I'm gonna write for easier, and then plus 1/2. You see here I have 2 sigma 1s. Here I'm subtracting 1. So in the end, I am left with still 1/2 the single terms, sigma terms. Okay, and then I have 2/3 minus half 2/3. Okay, no, yes, that cancels out, and I'm just left with a big 1. That's my term. Okay. Now, what does that mean? Let's check this a little bit. Okay, so what we just said is we take all this is saying is I have a bit formulation, y1 plus y2 plus y3 minus 1 squared. This converting to the equivalent spin penalty term would be 1/2 of some cross terms, the sigma 1, sigma 2s, plus 1/2 of the sigma terms, just a sigma 1 plus a 1. Let's think about this. What happens if I have 1 spin up? Okay, so let's have I'm gonna call this 1, 1. If I have 1, 1, obviously you look at the left hand side, that's exactly 0. And let's see what happens in the right hand side. If I have 1, 1, right, then the other are negative, so it would be a 1, a negative 1, and a negative 1, right? So sigma 1, sigma 2, one of them is, two of them, this and this, are going to be negatives, and one of them is going to be between sigma 1 that is minus 1 and sigma 2 that is also a minus 1, right? I hope this is clear. Because you're talking about a minus 1 times minus 1 plus a minus 1 times a 1 plus a minus 1 times a 1, right? Anyway, this would be 1/2 of negative 1 in here. And here, because I have 1, 1, 2 minus 1, so the sum of the single term, sigma term, is also minus 1. So I have minus 1 plus 1. This gives me 0, right? You can do this exercise and try 2 1s, try 3 1s, or 0 1s. You can try it. I'm not going to try it over here. The point is, what we just did is algebraic equation. So whatever this penalty term is, this penalty term would be exactly the same because we just did algebraic manipulation, right? And we tried the same thing. We tried, one case where there is 1, 1. In the bit term, it would be 1, 1, 2 zeros. In the sigma term, it will be 1, 1, 2 negative 1s. And we showed that this is indeed a 0 term. So minimizing this penalty term should be the same as minimizing this penalty term. They're exactly the same, right? But if I'm using Ising, would I minimize this term? I wouldn't, because the constant 1 is useless. So I only need to minimize this former part of it, and then I can get rid of the 1/2, right? So the term exactly, the penalty function is not the same, but the point is the same. I want to minimize this formula. So the penalty in spin would really be this, sigma 1, sigma 2, plus sigma 2, sigma 3, plus sigma 1, sigma 2, sigma 3, sorry. This is your edges, this is your cross terms, plus sigma 1, sigma 2, and sigma 3, right? That's the penalty that you want. Now, what do I mean by this? This sigma over here correspond to y1, right? Correspond to y1. But we know that this is not the literal term. Y is just in the first triangle, we call them y1, y2, y3. But in reality, y1 is perhaps the negative of x1. So in real world, let's call them, I don't know, sigma. Let's call them beta. Okay, so then sigma 1 would really be the negative of beta 1. So this is what we said. Y1 is x1 bar. Y2 is x, what was it? X3 and x4. X3 and x4. Y3 is x4, right? Then what you're testing here is this is beta 1 and beta 3 plus beta 3, beta 4 plus or minus beta 1, beta 4, right? Beta 4 is the spin version of x4, beta 1 is the spin form of x1, and so on and so forth. And you can complete this, right? So this is one triangle. If you have one triangle, you have a term like that. You have another triangle, you have another set of terms just like that. And in the end, you're going to collect terms. So suppose I have triangles where I have twice this happening. What does that mean? Let's say, let me give you a different example here. Okay, so I have two triangles. Both of them has x1 in there and x2. x1, x2. Let's say this is first triangle is x5, the next triangle is x6, right? So this appear, this kind of edge between x1 is a literal, it's no longer the y, right? Xy is, x1 is a global literal for my SAT problem. So this same x1, x2 appeared twice. Now for this formula, I would see one such thing, which is beta 1 and beta 2. And in this triangle, I will have another beta 1, beta 2. I would end up with 2 beta 1, beta 2. Right? That's why you get this formula. Okay? Like this edge, how many times this appeared? Why can't I? How many times this Iij is how many times Ij appeared in the original graph. Okay, and so in the end, this formula is really the same thing as that formula in terms of maximization, but they're not exactly equivalent, right? Because like we were describing, we got rid of the constant 1 and then we scaled it by 2, but you're optimizing the same thing. Okay, so this is point 1, which is how they got their formula. You know, it doesn't matter if you say, let's translate this into a MIS problem. In the end, you can find the telltale formulation. One is just that term, then you plug in whatever the real literal is. The other is the Kubo form. What I'm saying is the Kubo form is easier to work with for our problem. So we find the original Kubo form. Let's say, again, this is y1 plus y2 plus y3 minus 1 squared. This is minimized when you have exactly one of the y terms being 1. Okay? We don't want that. We want the expression to be, it's the conjunctive y1 or y2 or y3. We want this to be true. That's all we care about. We don't care about having exact term to be true. Exactly one term to be true. So what we want is y1 multiply y2 multiply y3 minus 1. Okay, we want this. We don't even need the square term. Why? Because this is Kubo form. It's either 0 or 1, nothing else. think. Let me think. We want to, yeah, if we want to minimize the term, we should use 1 minus, right? 1 minus this, okay? So if one of them, if one of them is true, no, I'm sorry. It's different. 1 minus y1, 1 minus y2, 1 minus y3. Yeah. This is not true. Okay, we want to minimize this term. If any one of the y is 1, the whole thing is 0, we minimize it. If none of them is true, then this is a 1. So instead of maximizing this formula, we want to minimize. We want to minimize this term, which is kind of not that different, except, this is 1. The cross terms, blah, 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 right? In the end, what happens is you should have a y1, y2, y3 term, a cubic term. And we know how to make this into a quadratic term plus an extra spin. So that's doable. Now, if we go back to the entire problem, the equation must be the total H Hamiltonian that you want to minimize is some constant A times some HA, some constant B times HB, and C times HC, right? What are the 3 terms? I think this is the thing that we were talking about, which is in a triangle, exactly 1 should be true. Okay, then that HB term is this. We want to swap that out with this term, huh? Red, with this red box. Okay, but that's not. And this term is giving penalty to links that are broken when you have, let's say, suppose this is x1 bar. Now then you have to add a link between this one and that one. Okay, so there is a term to minimize all these links. I don't know what it is, but I'm assuming you can figure that out. So in the penalty, what happens is they should be 0. Okay, there is nothing that cross them, and then we want exactly 1, and then the final term is HC. This is the number of terms that equal 1, right? So C is a negative value, so you want to maximize the number of terms that are true. But the interesting thing is, in there exactly 1, this is very easy. You're maximizing the number of literals. Okay, the number of literals is the number of terms, because we know that every term should have exactly 1. So I think this, in their case, it's simply sigma xi. Let's say be a negative number, so -1. Minus C is 1. So I'll just write -1. Right? That's them. For us, this term has to change as well. What is it to change to? We have to count the number of terms. That's 1. Again, that would be this red box. Okay, so let's say I have the first triangle is x1 bar, x2, x3. The next triangle is x2 bar, x4, x5, right? For us, what we want to do is, again, if this is true, it's 0, so 1 minus that is whether it's true or not. So we want to minimize this term 1 minus this thing for all I. Okay, and this thing is this term. It's 1 minus y 1 I1 times 1 minus y I2 times 1 minus y I3. Okay, so we have to minimize that term. Okay, I don't know what HA is. I think this is true. The principle is true. The math I may have a math error, so go figure that out. This will take some time, but I hope this clarifies what I mean, and we'll go from there.